Hi guys, let's discuss the concepts on electric flux through the cube. One charge, one cube, but there are different answers, and this is where most of the students lose marks in NEET. Students get confused between the different cases of electric flux through the cube when the charge is at different positions. So in this video, let's clear all your doubts so that you will never make a mistake in such questions in NEET. Right, so let's discuss the concepts. The first one, when the charge is at the center of the cube or charge is present anywhere inside the cube. When the charge is present anywhere inside the cube, let us say our charge Q is present inside the cube. When it is inside the cube, there are two categories of questions they may ask you. When the charge is placed inside the cube, it is well inside the cube, then first question or first category is what? Total flux through the cube. Total flux through the cube. Now what is the formula for total flux through the cube? Very simple, Gauss Law you apply. According to Gauss Law, total flux through the cube is given by what? Q by epsilon naught. Very simple. Direct Gauss Law. Second question or second category here. Flux through one face of the cube. Second category. Flux through one face. See here, in this case, how many faces are there? 6 faces are there. So, the total flux, which is Q by epsilon naught, divides into 6 equal parts. So, what is the flux through each face then? Say for example, if I want flux through one face, say I want flux through this face. If you want flux through one particular face, the flux through each face can be given as what? Flux equals to Q by 6 epsilon naught. Why divided by 6? Because there are 6 faces. So the flux divides into 6 equal parts. So flux becomes what? Q by 6 epsilon naught. These are the two different cases or categories of questions they may ask you when the charge is placed inside the cube. Now what happens if the charge is not inside the cube? Say if the charge is present somewhere here at the corner of the cube. When the charge is at the corner of the cube, let's do one thing. Let me consider here. Say that a charge is placed here at the corner. Say somewhere here. Say a charge is placed at B. Charge is placed at the corner of the cube. Then in that case, what is the flux here? Again, there are different cases they may ask you. First case is again same. What is the first case? What is the first case here? Total flux through the cube. Total flux through cube. Second case, flux through each face. Flux through each face. Now here, flux through each face, again we have two different categories again. First one, second one. We'll discuss them. First of all, let's find what is total flux through. What is the total flux through the entire cube? Now for that we have to understand, see, one corner of a cube is shared by how many different cubes? What do I mean? For example, if I am considering this set of system of cubes, look at this corner. Look at this corner. This corner is shared by how many different cubes? If I am considering here, let me do one thing. Let me take a different color here. Yes. This corner is shared by how many different cubes? Say for example, 1, 2, 3, 4, 5 and well this outside 6, 7 and this inside 8. This corner is shared by 8 different cubes. So that means if you are considering your charge is here somewhere here, it divides, the total flux divides equally between all 8 different cubes. So when the charge is present here, look at this, when the charge is present at this corner, Charge is not inside the cube. When the charge is when the charge is present at the corner, some flux will pass through this cube, remaining flux will pass through the other cubes. How many cubes? I mean, what is the total flux passing through each cube? When I take the charges at the corner, corner is shared by what? 8 different cubes. That means flux through each cube. Flux through each cube, yes. Flux through each cube can be given as Q by 8 epsilon naught. Why? Each corner is shared with 8 different cubes. Now, what is flux through each face now? Here it depends on which face are we asking. Are we asking the faces which is, are we asking the face on which the charge is present? Sir, you are saying charge is present at the corner. Then you are asking charge or flux through the face on which charge is present. What do I mean? Let's understand this. See here, this charge I am talking about. This charge is shared or present on which all faces? Look at this. This charge is sharing the face ABCD, right? This charge is also present on the face CGFB. This corner or the face is also shared by this face. Which face? AEFB. 3 faces, right? If the charge is shared by, this charge is shared on these 3 faces, or I can say it is present on, or that corner is shared by what? These 3 faces. If you want flux through those 3 faces, for example, if you want flux through these 3 faces, ABCD, flux through ABCD here, or if you want flux through BCGF here, BCGF here, or if you want flux through what? AEFB here, AEFB here. If you want flux through any one of these faces, flux through those faces is what? 0. Why it is 0? Imagine that there is a torch here at this corner and you switch on the light. The light does not fall on these 3 faces because it is present, or I can say that torch is present or sharing those faces. The torch is present or sharing these faces, the light does not fall on these faces. So similarly, flux does not pass through any of these faces. In that case, flux through these 3 faces is what? 0. Then flux through other faces except these 3. There are total 6 faces. In a cube there are 6 faces. Leave these 3, remaining 3. Leave these 3, remaining are 3. Flux through each face now. Flux through each of the remaining 3 is given by Q by 24 epsilon naught. Sir, why 24? What is your total flux through 1 cube divided by 8 epsilon naught we have? For 1 cube, I want through 1 face. This flux is shared by how many faces? Only 3. Because through these 3, flux is 0. This flux is shared by only 3 faces here. So divide by 3. When you divide by 3, 3 8s becomes what? 24. So flux through each face becomes what now? Q by 24 epsilon naught. Which faces? Except the 3 faces which are sharing the charge. Except those faces. Flux through other face becomes what? Q by 24 epsilon naught. Why? First of all, why this is Q by 8 epsilon naught? Because 1 cube or 1 corner is shared with 8 different cubes. Why this is 24 epsilon naught? Because total flux, which is Q by 8 epsilon naught, is divided into 3 parts. Why 3 parts? Because flux through 3 faces is 0, remaining are 3 faces, divide by 3 here, 3 8s becomes 24. This is the second case. Third case, when the charge is present on the edge of the cube. For example, let's talk about this. Say when the charge is present here, somewhere here on the edge of the cube. One edge is shared by how many different cubes? If I am talking about, for example, if I am talking about this edge, you can see here, this edge. This edge is shared by 4 different cubes, or even you can take this edge also. This edge is shared by 1, 2, 3, 4. 4 different cubes. Each edge is shared by 4 different cubes. That means again there are 2 cases here. First one, total flux through the cube. Total flux through the cube. Second one, flux through one face of cube or each face of cube. Better we'll refer it as one face of cube. Now here again we have 2 cases again here. Again we have 2 cases. Now first thing, total flux through cube. I told you edge is shared by how many cubes? Each edge is shared by 4 different cubes. That means flux through each cube becomes q by 4 epsilon naught. Total charge is q. Total flux produced by charge is q by epsilon naught. But flux through one cube, flux through the cube is given by q by 4 epsilon naught. Now again there are 2 cases here. What are the cases? Flux through, if you want the faces here, say for example, if I am taking charge is present on this one here. Here charge is present on BC. BC is shared by which faces? BC is shared by ABCD, ABCD, or BC is shared by BCGF, BCGF. Again, flux through these faces is 0. Flux, see, charge is shared by which faces? Through that flux is what? 0. Now in that case, remaining how many faces are there? Remaining faces, or let's say yes, or let me do one thing, let me write this as what? Otherwise. Otherwise, if except these 2 faces, remaining any of the 4 faces, flux through each face or one face, any other face except these 2. See, these 2 flux is what? 0. Remaining how many faces? 4 faces. So this entire flux divided by 4 again, because the flux is divided into 4 parts now again, because there are 4 faces left here. 4 4s are 16. That means my flux becomes what? Flux through each face becomes what? Q by 16 epsilon naught. This is the case when charge is present at what? The edge of the cube. Let's consider one more case. The last case. When the charge is present on the face of the cube. For example, say if the charge is present on this face of the cube, say BCGF. Each face is shared by 2 cubes. For example, if we consider this face is shared by 2 cubes. One is here, one is here, one left, one right. Each face is shared by 2 cubes. That means first case, total flux through the cube. Total flux through the cube. Right. What is the total flux through the cube? Flux I can write it, or second case I'll write here. Second case also. Flux through each cube. Flux through each face or one face of a cube. First one, total flux. I told you each face is shared by 2 different cubes. In that case, flux through each cube is given by q by 2 epsilon naught, because each face is shared with 2 different cubes. In the second one, again we have 2 different cases. First one, second one. First one, which faces? BCGF. I told you this face is sharing the charge. Flux through that face is 0. Remaining faces, otherwise. How many faces are left? Cube has 6 faces. Out of that, leave one face. Remaining 5 phases. Total flux is divided into what? 5 parts. 5 twos becomes what? 10. So flux becomes what? Flux becomes what? Q by 10 epsilon naught. Q by 10 epsilon naught. Because 5 twos it becomes what? 10. Right. Yes. So these all are the different cases of what? Electric flux through the cube when the charge is placed at different positions. Now what kind of questions do they ask? Let's discuss some 2 questions on this so that you will get an idea of what kind of questions do they ask. First question. A charge Q micro here is placed at the center of the cube. Flux coming out from any one of its faces. First thing, center of the cube. Second thing, one of its faces. What was the case? The case was here. When the charge is placed at what? Center of the cube and flux through one face. What's the formula? Q by 6 epsilon naught. Q by 6 epsilon naught here. Now here in this case, the question they are asking what? Flux through one face. But charge is what here? Charge is Q microcoulomb. Q micro is 10 to the power minus 6 divided by epsilon naught, 6 epsilon naught, because they are asking through what? One phase. So which answer? So answer is option D, Q by 6 epsilon naught into 10 to the power what? Minus 6. Right. Second question. What is the flux through cube of side A if the point charge Q is at one of its corner? They want flux through the entire cube and charge is present at corner. What's the case? Now here we have discussed just now. Yes, it is edge. Yes. They are asking flux through the entire cube when the charge is present at the corner. Answer is what? Q by 8 epsilon naught. So what is your answer now? Q by 8 epsilon naught. So your answer is Q by 8 epsilon naught. Option B. It does not depend on the size of the cube. Side of the cube. Whatever the side is. A, 2A, 10A, whatever the side is. Flux remains same. What's the answer? Q by 8 epsilon naught. Right. So these are the different categories of questions they may ask you based on what? Electric flux through the cube when the charge is present at the different positions. Right.